Well, good afternoon. Thank you for joining us today for SME's Technical Community and Aerodef Manufacturing Satellite Session. In today's webinar, Multifunctional and Smart Aerospace Coatings, you'll learn about aerospace coatings, how they're selected, and various use case applications. We will address detection, responsiveness, and self-repair properties of smart coatings that can reduce costly malfunctions by enhancing both functionality and durability, extending the service life of the final product. I'm Carl Mitroff, Aerodef Manufacturing Conference Manager, and thank you for joining us this afternoon. Before we get going, I just want to cover a few housekeeping items about this platform. You'll recognize right away that your microphones are automatically muted, and if you have questions regarding the functionality, please use the chat feature. If you have technical questions you would like to pose to our guests this afternoon, use our Q&A box in the webinar platform. And of course, in the event of any technical glitches, we are recording this presentation and we will make it available on our Aerodef website. Now I'd like to introduce today's moderator of this webinar, Mr. Louis C. Dorworth. Lou has been involved with the advanced composites industry since 1978. He's been a senior member of SME since '97 and is currently the chairman of the Technical Community Committee with SME. Lou is a composite materials and process specialist with experience in R&D, material and process engineering, manufacturing engineering, tool engineering, and tool fabrication. He is currently the manager of the Direct Services Division at Airbus Training Resources out of Reno, Nevada, and has been with them since 1989. Thank you, Lou, for moderating today's webinar, and I'm going to kick it off to you.
All right, great. Thank you, Carl, for that introduction. We're all looking forward to a great webinar. As Carl said, this webinar is going to discuss aerospace coating selections, applications, detection, responsiveness, and self-repair properties of smart coatings that can potentially reduce costly malfunctions by enhancing both the functionality and the durability, therefore extending the service life of the product. Our speaker today is Dr. Jamil Bahachi. Dr. Bahachi is the president of Innovative Technical Systems Corp., engaged in design and production of specialty coatings, adhesives, and composites. He joined the company after spending 35 years in various technical and managerial capacities at BASF Corporation, DuPont, PPG, and Arco Chemical Companies, as well as a professor of polymers and coatings at the Eastern Michigan University. Dr. Bahachi is an author, editor of 7 technical books in related areas, an active industry consultant, and is frequently keynote and invited speaker in industry technology forums. He conducts training courses for the U.S. military, technical organizations, manufacturers, and suppliers worldwide. He also serves on the Technical Advisory Board, Technical Council of Liebherr Aerospace in Germany, Paragon Industries, and Mitsui Chemicals. So without further ado, I will pass the baton on to Jamil for his presentation. Jamil?
Hello, good afternoon, because everyone is in the US, so there will be a good afternoon as opposed to maybe in someone in Japan or so. So we will move on. I have been given Lou talked about the smart coatings and their values and things like those. We will talk about those as much time that we have, of course. Typically, I present this for a couple of hours, or sometimes for 2 or 3 days or so. However, I'll put all that together in a format that I have put already, but in a format that will be easier to understand the majority of the information that can be relayed to what we just talked about on the topic. We will talk about the smart materials, what they are, what they do, what they can do, and how far we can go with that. It is not just that for airspace, but this particular one we're talking about for aerospace as well. And some of them are being used, of course, and I have worked on some of those airplanes that you see, the maybe middle one. and bottom one, top one as well, and applied some of the smart materials onto those things, which we might be able to talk about those if we have time. Next slide, please. By the way, he talked about that I go around and around and around in so many companies and so many, those are from Tinker Aerospace, from Robbins and from Hills and this and that. So to show that I do exist, right, and from how small I look like compared to the, those giant airplanes. But imagine that they get painted, that there are 4 or 5 on the top of it, there are 4 or 5 layers of it inside, and everywhere else is one. Let me show you this next slide. I hope that at that point you can justify that what we're talking about. Folks, don't get me wrong. You are wearing coatings in your body. If you took a shower, you have coating on it already. Whatever we do, there's a coating on it. Maybe that's a God-given coating, not necessarily we apply it ourselves, but everywhere, everything contains a layer of coating. Plants have the same stuff too. But let's go back to our own discussion. Coatings are on airplanes everywhere, from the smallest that you can see, as I say in there, right in there, bolts and pieces, the screws, all the way down to the everything that comes out. Because without it, it would not function for a variety of reasons: corrosion, protection, and responsiveness, and things like those. So I would say no way to build one without it. It's impossible. In certain another language, I would say imposible. How about that? That would be Spanish version of it. So I'm not Spanish, okay? I'm Italian. So as you can see, coatings are multifunctional. If someone tells you that tries to sell you a coating which is multifunctional, they're lying. I'm sorry. All coatings are multifunctional. The fact that coating sticks, it stays glossy, applies and dries, that's a multifunctionality anyway. But what we talk about in the Air Force airplane or so, we're talking about protects, right, elements of the weather. How about that? Look, imagine that a plane is taking off from a tarmac at 110 degrees or so Fahrenheit, going up there to a minus 50 in about 45 seconds. See how fast that stuff cools down. There's need for coating for that, because if you put a regular coating on it, it's gonna just fall apart. So it puts in there the right one, of course. Modify plastics, okay, rubbers, composites, and metals, because by themselves they cannot necessarily function. And all the other ones, because I'm not going to read it, but you already have the slides. You can see that some of them are definitely have to be there, like a stall, for example, or drag reduction and things like those, or anti-freeze or so. Next slide, please. So I'm assuming that you have had this thinking, asking this, what is the smart coatings? What is it? Okay, I'm not going to read it. I'll leave it for you to read that. The second line, I read it for you. Smart coatings made in such a way that they can respond to some type of a trigger. You put light to it, it does something. You put cold to it, it does something. You do something else, it responds differently for that, for the right way, of course, not a wrong way always. So this is important. For example, the first one, next slide, please. There we go. That lady that's shown up in that thing, that smart coating was made 57 years ago by Corning, the glass company, that no one called it a smart. No one still calls it a smart. But as you know, if you go outside, it darkens. If you come inside, it turns its color on its own. So it's just smart stuff. Next, please. This is rubber, which we use in an airplane, in so many places in an airplane, for example. Look, as a function of stress, you figure out what that really means. Stress, either by heat or by freezing, for example, color changes. If color changes like that, most likely one would see that. Not that it's going to go back. It will change color from what it used to be. Then the next time when pilot or someone else checking the thing, you can see, oh my God, this color has changed. So it's time not to fly or fix it. Next, please. This other slide shows that as a function of changing the distances between, so as we know, we have bolt, we have body, we have steel, we have a composites. So as things change, color shows up. And that actually the word writes in there. That can be corrosion, the word corrosion, because this has happened on the bridges, for example, not on airplane, on the bridges. So if the gradually beginning to corrode, it will show corrosion on it. I hope that you don't drive on it, and I don't drive either if it shows a big sign of a corrosion on it. Next, please. This is self-healing. This is real, folks. It is not hocus pocus. You take the coating, once completely cured, scratch it. It doesn't take only 2 point whatever seconds or so. It takes about 24 hours. You come back next day, voila, it is completely, there's no line in it. It's healed up. You could ask this question, how long can it take that thing? I have no idea. It's just that it does once. If you do somewhere else, it does the same place, I don't know. But it will. This is known that it will continuously heal itself because so that information is inside the coating. The same information that we have on our bones. Once bones broke, you bring them together in proper way, they will heal because information of a healing is put in the bone to begin with. Here, the same information has been put inside the coating to heal if it's scratched under the force, of course. Next slide, please. Here, for example, we're talking about the difference between the typical coatings and the smart materials. I'm comparing that with what we have in nature. In nature, if you go out today, any one of you, there's a prize for it, okay? Take a look at the leaves, underneath the leaves and top of the leaves. Always top of the leaves is darker than the bottom of it. All leaves in the world, almost. Well, I take it back, not in the world. I have not seen the whole world yet. So the reason for that is that the top side is it's under the sun. It has no choice but to change. The same in the trunk of the tree. Take a look at it today if you go out. The side of the tree, which is toward east and south, is darker than the side of it which is toward the north, because north doesn't get much of a sunshine. So the tree has to abide by that and then fix itself so that it can survive. Next slide, please. Here, why smart coatings? I won't read this stuff. I leave it to you to take a look at it, because we do have so much stuff in it that it has to respond to it. Right? For example, control function on demand. How about that? For example, that plane of the F-22. I worked on this F-22, for example. We want that to suddenly disappear from radar. How about that? Just make it disappear. Well, you just push the button. Not this particular one, okay? I'm not getting that our military stuff out, but it can disappear easily. Respond to something. It will do it on its own, okay? Because system are put into the body of the plane and all parts or this and that. So next, please. This is a coating which is not being used yet, but has been already made, and it's about to be used because, as you know, typically when we try to put those into airplane, it goes through a lot of things for approvals or so. So this is called shark skin. So as you can see, that's how shark is able to swim with such a big body with no difficulty at all, without any drag. So this is what is gradually being added. The hydrophobicity allows water channels through that without any issue. Otherwise, we will be stick to the metal and or composite so that it causes drag. Next, please. Here I'm trying to bring it to you to the smart and multifunctionality of that. There are differences between smart and multifunctionality. Of course, all of smart coatings are multifunctional. But not all multifunctionals are smart. I hope you follow what I'm trying to say. All the smart coatings, because they do different functions, multifunctional. But multifunctionals are not all smart. For some of them to be, as you can see, for example, it's a multifunctional, it's antibacterial, for example. It's a coating, but it also kills viruses and bacteria as well. But the other one over there, it's only a smart and responsive, because that polymer that you see there, I'm not going to get into a polymer part of it, but that one, we have used that thing in a, or not myself, but other people too, to make put on the hair, and on the soap. Folks, I don't have, as you probably see that I don't have much of a hair, but if I wanted to have a curly hair that day, I'll use that particular shampoo. Once you put the shampoo in there, you put a hair dryer, then your hair becomes curly. How about that? Just keep on going with the curly hair. Nothing particular, just the polymer does that, because all shampoos contain some sort of a polymer. Next, please. Take a look at this. Ordinary coatings, as I say in here, are designed to perform only one thing. How about that? And you know, and I know, and we do that, we say that to everyone else too. Be sure that lasts forever. How about that? What if bones break then? But God knew that better, because if bones once broke, they can also be repaired. They come back together. So, on the other hand, traditional materials, of course, the coatings, are multifunctional, as you can see. On the right side, corrosion sensing coatings. How about that? You don't need to do much stuff. You allow the coating in there. If there's a corrosion, it will send a signal to your iPhone. How about that? Or how about your other phone, not just the iPhone? You end up a click, ending up with a noise, with something, tells you there's a corrosion somewhere. Whoa, that's a lot. And or self-healing, for example, or touch-sensitive coatings, for example. You touch it, it changes color, as you know that these things do exist. And or, for example, anti-fouling, which we use it in both in airplane and also in the ships and boats and things like those. Just to bring you one thing, which is not a airplane related, aerospace related. This other one, click please on it. Click. This does exist. It is not a show. It's real. Under the coating, there are pigments, and which are prism type pigments, which actually responds to electricity. Someone is sitting inside, holding on like a knob, like a radio knob, like old times, and it turned that onto different voltages. As you increase the voltage, color changes. You go back, it becomes the same color it used to be. You see that it's stimuli-responsive as a function of changing the electricity. The color is also changing. Again and again, it could be used as a getaway car. How about that? Not for me. How much time we have, Lou? Another 10 minutes or so? Or longer, hopefully?
Yeah, we're good for another 10, 15 minutes.
Okay, yeah. Cut me off when I get to that thing. I get so excited about these things, okay? So,
very good.
Next slide, please. By the way, you saw that on the picture over there. That was a 787 Windows, right? That you sit there and you touch the knob, and it changes, darkens or becomes lighter or so. So as you can see, tiny bit of polymer underneath, the coating underneath between two glasses does that stuff. If we can do that, I think we can do way more than that, or expanded, of course. That's only to show in our presentation here. Next slide, please. So let's get to the thing here. The one that you see, which are in yellow, they're multifunctional. They're not necessarily smart, because antimicrobial really cannot be that smart. It only kills. That's not being smart to kill something. But the white ones that you see in the slide, those are actually, for example, pressure sensing. Pressure sensing has been around for quite some time. In Seattle, they use that quite often, because wings are put in the chamber, and then you see that how much force it can take, how much wind it can take without going bad. So these have been around quite some time. Or self-repair, for example, changing shape, memory, things like those. They all do exist and have been around for quite some time. Just to let you know, I got interested in these myself back in 2000 when the word smart coding came out. And then I was at the university at the time. So we said, why don't we just come up with something ourselves, just for fun of it. Next click, please click on the other one. There we go. That ducky, it's sold in Bath and Beyond, at least then, and for $2.50. I get about a cent off of that each. Not anymore. So as you can see, as a function of a temperature, which is 42 Celsius, 42 Fahrenheit temperature. So at that temperature above that gradually begins changing color. Indicates that one would not put the baby in a hot. If this is to show that can be made. By the way, someone is going to ask, like anyone else that in technology, will say, how expensive is it to make that stuff? That uses only 2 milligrams of a dye. The one that we used to use in school, actually, when we titrated something. That dye is not expensive, but put in the little area of the duck, it changes color. So therefore, making a coating is not going to be all that expensive. But see its value of it. Not on a duck, but on airplane, of course. Next slide, please. So that brings us to what we just talked about. On the left side, if you can look at the challenges. I say I've been doing this for 20-some years now. The first question has always been, how difficult is it to make? Second has been, how expensive is it to make? The third one, how difficult is it to sell or buy? It's not a question. It's a reasonable questions. What if you only put 1 milligram into that duck? And 1 milligram is not expensive, actually, that dye. It just exists. It's indicator that you and I use in school. Okay, indicator. We use the same as a food dye coloring, right? Similarly, which is not even expensive. But that changes color as a function of time or temperature or so. So there is if you can please click on the middle one, see what happens. That paint, you've seen it in stores. It comes pink, the for ceiling paint usually. It's pink, nice pinky color. After about 3 minutes or so, once it dries up, color changes into white, disappears. There are values to it, of course, that you don't, every time, if you're doing a ceiling, for example, a wall, most of us, if we do that ourselves, we go over it again and again and again. Then we use a lot of paint. But if you only put up a pink, you're not going to put another pink on top of the same pink. You're going to move on to the other side. So you use less paint, actually. So the question is going to be, again, any one of you would be asking this question, how expensive it is to make that stuff. This uses 2 drops per gallon. Folks, 2 drops per gallon of a dye, which is commercially available. That only is sensitive to a pH, because all of the latex paints are basic. So when you apply that, ammonia evaporates. Once ammonia evaporates, then you end up with a neutral. And neutral is white. How about that? So 2 drops, you get $5 per gallon. How about that? That's pretty darn good. And so that is as far as the selling stuff. But can that be used in airplane? Yes, of course. It's being used too in certain areas or so as a function of many things. So too high a temperature, for example, or getting too old, for example, and things like those. And or corrosion response, for example. Next one. Folks, very quickly, I'm not going to say anything about this stuff too much because we are out of time almost. And take a look at it. At the beginning, people said it's impossible to do something. After a while, it becomes possible. Very simple. And then you and I say that, how come I didn't do that myself? It was that simple. You take a look at on top, for example, you can see an airplane with a winglet. Why do we have winglets? Someone just looked around and saw that the eagle had a winglet. All birds have a winglet too. They said, how come we put that in there too? They did that. They figured out if you put that in there, you end up with a 6.8% less gas used by airplane. How about that? But now it's so simple to do this stuff. Almost all of if you go to hotels nowadays, you can see that their shower curtain is round. It's a circle almost. How come we didn't know that long time ago? Someone came up with that, just way better that way. And it takes a more area, of course, right? So the water doesn't pass the outside anymore. Next, please. Next. These are some of the commercial available ones that have been around for quite some time now. For aerospace coatings, we have a temperature with a hydrophobicity, for example. So there's not much of a freeze on it, as you know, on the wings and other areas, of course. And a durability monitoring, it sends a signal to your computer, to your cell phone, to anything else, or by visually looking at it, it changes. If the durability is gone, compromised, color changes. So therefore, it's time to fix it before some disaster happens. Next, please. This is one example to show that how self-healing works. Every time something goes bad, it has started a long time before you and I knew that thing. Right? Things get older and older and older. We don't notice it until one day it falls apart. So as you can see here, I showed in the picture that there's a crack. Crack goes on. Gradually what's inside fills into the holes of cracks. And then on the right side, you see the purplish color. That means that it's already glued together. Next, please. This is one of those. He's going to come and cut it. There is no glue in it. There's no stickiness to it. Seeing is believing. There we go. The same weight. Stuck. Next. This is another one. Look at scissor. It's just cutting it. It cannot be magic. The same piece that fell down, put it back again, together, press it a little bit. By the way, a couple of seconds because I don't want to rush at this point. So you can see that it's stuck. It will be stuck. It takes about 24 hours, okay? Not this. Next slide, please. Similar to something smart, for example, here. Folks, we put, or they put, not we, I don't do that myself. So we put corrosion inhibitor into coatings, like a cerium, usually for aluminum. And then, but by the time that we end up with a corrosion, cerium is already gone. It leaches out. What if we put that inside a capsule, which we have done it a long time ago? Military uses right now, and then it only responds when there's a corrosion. How about that? Corrosion that is at high lots of water, lots of basic solution, and also lots of heat. All of those can cause the capsule to rupture. When it ruptures, it exudes out what is inside. And then it stops at that point from corrosion. How about that? Not before that. Next. Lou Do I have 3 minutes or not?
Oh, yes. You're good for another 5 to even 10.
Oh my God, I'm going to tell you stories a lot. Okay.
Oh, there you go.
Not really. Okay. Folks, we talked about aerospace. I do this on almost daily basis, okay? Not really, a little more than daily, less than daily, weekly basis. How about that? Folks, every time I'm in basis and here and there, these are the issues that we have. Material properties and process and applications. Those two things are the ones that makes our coatings to go or no go. So the first thing, as you know, on the material properties or so is adhesion. Coatings function by adhesion. Without it, forget it. It's not the beauty of it. For airplanes, we want to look for adhesion. Mechanical properties of the coating. It should not be easily removable, but surprise, because I hope you can believe me. I go to these bases often enough. With a fingernail at times, don't tell anyone, okay? I'm able to sometimes to scratch it. That paint is not going to last because when it goes up into the, very, very high up and cold, it's going to begin cracking. And all water goes on it, with enormous amount of rain or so the humidity and all that stuff, or maybe in the base, for example, at 110 degrees or so, gradually that goes bad. And the functional properties of the coating. Second, if you look at on the right side, surface engineering. Folks, I have been through this for years and years and years, and I've been insulted many, many times, which is fine. Okay, I've been on to the commander or so. We have talked about those as well. That if the surface is not cleaned properly, coating cannot stick. Coating will only stick where it has been clean, or as we call that, ship-shape clean. An application. Folks, application says that, for example, 2 mil should be thickness. I walk on the plane, on the wings, I end up, for example, 2 mil in there. That 2 mil is not going to function, or 8 mil. How about that? 8 mil is not going to function, and a 2 mil is not going to function. So this is important to do that, to look at. And cure. At times I have found out that the paint has not been cured. Okay, if paint doesn't cure before you take it to the for flight, it is not going to cure anymore once it goes to the minus 40 degrees, folks. So then the whole system falls apart, which we unfortunately, when we analyze it, we figured this out. It happens. Next slide, please. I hope you don't get mad, because this is the reality of life, of course. I would say key performance attributes of the typical aerospace coating are substrate and surface preparation. If we do that, then we have gotten almost 75% of the functionality of a coating. So substrate cleanness and a surface preparation. It is the one that many of the problems actually stems from. And again, myself and many, many people have already figured this out too. Then it becomes application and process of that. Application at what film thickness, for example, it should be uniform, and also the process means how long you wait that to cure, for example. But we don't put the airplanes in the oven like they put it in the cars in the oven. So therefore, it would sit in November, get painted in a cold environment, and also in the middle of the summer also painted. So as you know, there's a difference between the places, right? One cures. But system calls that after 24 hours or so, it is cured. Come on, man. 24 hours at minus some degrees is different from 24 hours at a higher temperature. Material, of course. Typically, the coating materials, they play a major role, but not compared to you may have the best of the coating in the world, but the substrate is not right. It's not going to do a good job. Or application was wrong, it's not going to do a good job either. Most of the time, the users go after someone who made the paint. I am not the one to make paint. I'm not taking any sides, of course. But we figure out that paint was good, but one part of a wing is good, better than the other one. So that means the paint was really good versus the thickness or thinness of the coating. Next, please. Here, I want to show you one thing that if you have not seen it yourself, because again, this is my drawing, but it's a reality under a microscope as well. So I would say in order for paint to stick, coating to stick, it must allow the coating to wet the substrate, as to flow on it very simply and easily. And it must also be a stable interface, because like a steel, for example, like iron, if you rub it clean, if you sand it, it's not stable because it begins corroding right away, because corrosion itself is a protective layer on its own. So once you remove that, it's no longer. Aluminum similarly. Shiny aluminum actually corrodes much quicker than the grayish aluminum, because once you remove that coating, the corrosion off of that thing, the white corrosion off of that thing, then it begins corroding much quicker. So it must also enable the formation of the bonds, right? So we really have to be sure that surface is awfully clean. That's why we anodize it, we do this, we do that, we do plating and things like those. So the objective of the surface preparation, therefore, I would say, is to be consistency, to passivation of the surface, so it doesn't corrode anymore, and should also be reproducible again and again. In places that I go often, while I'm there, everything works. Once I step out, it doesn't work anymore. So it looks like that they should hire me for that. But that's a different story. Next, please. Folks, be my guest. Those colors that you see on the squares that you see, coating and substrate, that's a better single coat coating. On the right side, better primer and top coat. Look, stuck tenaciously together. At the bottom on the left side, do you see high porosity in there? Don't tell anyone. This coating is one of the darling airplanes we have, okay? Was. Because we figure out that why this is not lasting long. Almost 50% of the coating, as you can see, has a porosity in it, holes in it. Imagine that water passes through the system, which does, and falls inside those holes. As you can see, it produces vacuum, produces over there. It also turns into a vapor, right? Expands, contracts, freezes inside those holes. This is why it happened to the airplane, because when it flew, this airplane, when it came back after the medium flight, because after everything's done, the airplane goes up, as you know, and it takes a flight, right, for practice. And then by the time it came back, it looked like a tiger, because some of the paint actually peeled off because it had all these holes in it. I'm assuming the very on the right side, very high porosity. I don't know if you can see those things. Since you cannot see that, I made some in there for you to see that. Click, please. If you click, there we go. Those are the areas that bubble formed underneath. How about that? They put the paint in there, but because underneath there was oil apparently, or something was not really clean, so therefore coating sat on it, right, and cured or dried on it, but the holes were there. Imagine that if this airplane flies, water gets inside it eventually, not right away, right? Eventually gets in there, and then expands, contracts, causes failure. Look at this. That's more than 50% of the area is as you can see, contains the hole in it. Next, please. This is I think maybe last slide that I had. Folks, don't get me wrong. Read that stuff. Corrosion is a natural phenomenon. We cannot prevent it. How about that? The sooner we come to the reality, the better it is. All we can do is to delay it. How about that? We can delay until it becomes someone else's problem. How about that? Not my problem. So that is why car companies tell you that, for example, 5-year warranty, right? 7-year warranty or 10-year warranty. They never do that forever, because it's impossible to do that forever, because corrosion is a natural process of something. if we had one of those 1-day talks or maybe 3-day talk or so, like in a company environment or so, we will discuss those in detail. It's much simpler to understand. But anyway, I put them there to show you that these do exist, and then one way for us to conquer this, to be sure that to be able to end up with the rest of the coding, we will need to know what the film is, how it has been formed, how good the film itself is, rather than sending that to the environment until it really falls apart. Next slide, please. I wish we had more time. I leave it for you to read. And I hope that you agree with what I say, what I wrote. Broaden material utility, definitely. Extend, right? Lifetime. Reduce overall cost, because you're putting only one thing without a primer, for example, underneath, but it lasts longer. If just that I have been told in the basis, if one airplane that lasts 1 year longer, that is millions of dollars on its own, versus every 5 years or so to make a naked plane, as you know, remove everything else. So 1 year is a lot of money on its own. Multifunctional coatings, of course, they do increase the efficiency. We all know that. We don't put too thick. We want it too thin, because we know how it shows this stuff. And then a few other things I see at the bottom of it. The bottom of it, the very thing at the bottom is not my word, as you can see. It's the Einstein. Look what he said. Not to memorize things, right? Just to think that there are ways of doing things. Someone like Lou over there has been doing this all his life, right? We did stuff, we didn't work, we end up with something else. How about that? We just learned over as we moved on, rather than reading whatever a book said, and it didn't work sometimes. Okay. Next, please. Folks, thank you so much. That's my email. By all means, if you have any questions that we could not answer at this point, like a time or so, by all means, shoot me an email. No charge to it, because I've been doing this all my life. That's how I learn, by answering questions. By all means, it was a pleasure. Thank you so much. Lou, it's all yours.
Well, thank you, Doctor. I'd like to now turn it over for questions and some answers from you. I do have a question here about highly conductive coatings. Have you had any experience with highly conductive coatings, such that might be used for either EMI protection or perhaps lightning strike protection that is rehealable?
Yes. As you know, conductive coating have been around for quite some time, right? The whole body, just long time ago, was made. We just need to take the same stuff and put heating agent into it, so that when it cracked, for example, those things can move toward the scratch area, the cut area, which is standard process. Yes, this does exist actually, healable. Of anything heatable. It doesn't have to be house paint. It doesn't have to be car paint. So that the conductivity, it does not change any of that thing.
Yeah, and I think particularly there's a lot of interest in graphene as a conductor, ultra high level conductor. And so I think that's leaning in that direction, that what kind of, as we move forward in the ability to use those products in the nano products, that this kind of thing with a conductive coating might be easy for you to put together. But as far as I know, nothing that is currently done.
It is done. It is done. This is, as you know, ARL approves these things. The military ARL.
Yeah.
They do approve these things, and I know that they have been through this for maybe about 20 years, 10, 15 years or so, that they have been working on these and to approve it. As you know, the military stuff takes a long time, right? We all know that thing. And so again, to let one thing I explained that you mentioned conductivity is one thing, with or without anything else. Uh, so the coating is urethane. So we put a urethane curing agent in it. That's all. So
Yeah,
urethane curing agent is the one which is going to heal it. It really doesn't matter what the coating was, right? What's
sure.
composition of the coating, as long as you have something in there that which is going to ooze out, ooze in, and fill the holes or crevices, that will do the job.
Yeah, it'll keep it together. I
Yeah,
got it.
keep it together. Correct. Exactly. Keep it together. Yes.
Yeah, I know those of us in aerospace, especially composites, would love to have a coating that is insulative on one side, where it is an
Mhm.
insulator from the carbon, but on the outside of that coating, we have maybe another coating or another level of the
Yeah.
coating that is the highly conductive surface. So
Correct. Yes.
that ideally would be the mix. So I open it up to others to engage with any questions they may have. Use the little Q&A icon to the right of your screen or wherever it might be on your screen. We can entertain your questions. We've got a little bit of time here. So please enter anything that you might have for Jamil. And I'm sure he would be happy to answer those. Also,
Easy
if you
question, please.
yeah, and if you actually took notes on his contact information, it would be helpful after the event. If you have anything that you want to ask him, please contact him directly. Um, Next on the thought is there any study on the shark skin coating? Where as far as the little ridges that are micro ridges that cause the hydrophobic condition, maybe even super hydrophobic. I'm not sure
Yeah.
what level we would talk there, but has that type of coating been tested under erosion conditions? Like say on the leading edge of a wing or lightning, or excuse me, an ice boot type thing, where that kind of technology might be adapted to help the liquid forms roll off of there, and or protect from ice in some manner.
Uh, Lou, what I know is just that I have visited the company in Germany, that I have seen the coding that they are working on it. And I don't know but how far that has progressed.
Okay.
Again, that is they're making that for European. It doesn't matter. It's ally, right? Like, we end up using that too ourselves. So the same company that you have it in my resume, you saw that thing. So that company has BASF makes this shark skin coating for now.
Oh yeah.
And
Okay.
everyone's going to also follow this, probably the same suit, but they have the patents on those. But I don't know that how far that has, how advanced, and what are the issues with that. I doubt that is issues because they already sell coatings to the airspace,
Oh
so
sure.
they know what the platform's supposed to be, right?
Sure. Yep.
And what it so therefore all they have now they have married, that a good coating with a hydrophobicity with a channel in it,
Yeah.
because
Yeah. Yeah.
in the past we did not have channel, we only had, as the smooth surface. But now figured out that a smooth surface is not the only one, because they just figured this out, that even leaves have it in a shark skin. Leaves are not really that smooth, as you know. If you look at the leaves, they're just ups and downs so much, because apparently those are the ones that actually channels the water, right? Versus the whole thing falling, because none of them are really smooth, you know. So yeah, I don't know really how far this stuff advanced, and when it would become something that we could use, anyone can use.
Certainly. Yep. Any audience questions that we can answer for you? Well, I would like to thank you, Doctor, for an excellent presentation. And I ask everybody to stand by for a moment while we just talk about some following presentations that are to come. Turn
Thank
that
you.
back, back, over to Carl. Carl, Jan?
Yeah, sorry, I had to get myself back in. But no,
Okay.
thank you very much. Thank you very much, Jamil and Lou, for your time this afternoon. A great discussion, very informative. A lot of great content that was presented today. So thank you for your time and appreciate you
Cool.
spending it with us. Also appreciate the time that our audience took out of their day to spend with us and our continuing satellite session webinar series. We will have, I think, 2 more satellite sessions that we're going to be facilitating as we continue to lead up into our AeroDef conference and exhibit later in November, November 16th through the 18th in Long Beach, California. So look forward to seeing possibly some of you folks there. And as we get back into our live face-to-face events, we're looking forward to that. Next month, just a quick shout out and a promotion for next August's August satellite session. We're going to feature our webinar on next generation additive manufacturing, and registration for that webinar is now open. Again, as Lou mentioned, if you have questions for Dr. Badachi, feel free to reach out to him, or you can send an email or message me directly, and I'll make sure that I can get information out to him, or Lou as well. Lou is a very active AeroDef conference advisor, so any questions you have for any of these 2 gentlemen, please feel free to reach out to me, and I'll be more than happy to forward. Appreciate your time. Thank you for attending today, and I look forward to seeing you in future broadcasts. Have a great
Thanks
rest of
all.
your day.
Thank you.
Thank you.